So it needs to reach the threshold and then it forms the product. So यहाँ पे you have an unstable intermediate. In this case, let's say A, B. So usually this may be the pathway that the reaction goes. So usual may be A plus B react, they form intermediate AB, and then that rearranges into C plus D. But with a catalyst, alternate pathway matlab, like the mechanism itself is completely changed. So you have A plus B. Now we have added catalyst in the mix. The intermediate could be a different one with the catalyst, where it is C will get too confusing. Let's say P. Then this may be ABP. And this will give C plus D your usual products, and P is again released. So P is unchanged, beginning of the reaction, end of the reaction, but a different intermediate is formed with the catalyst. Iska energy, if it happens to be lower than your AB intermediate, then of course it's easier for AB along with P to form that other intermediate. So with catalyst, we'll start looking like this. So this is the intermediate with catalyst. This is what we mean by a alternate pathway. Abhi, like any substance, like there may be many different possibilities of forming like intermediates and all. Now, all of them will not improve the reactions. Like some of them, they may be higher energy, so it'll make the reaction slower. They may be of equal energy, in which case there won't be any change. But when it so happens that iska energy is lower and it's easier for the molecules to take this pathway and like get to C and D quicker than your original way, that's when we call it, okay, that's a catalyst for this particular reaction. It's making it faster, it's going to speed it up. This is what the graph looks like with a catalyst. So you can see that the activation energy is also reduced compared to your original. So if you compare the overall, like delta H remains the same, entropy remains the same, because if you look at the initial and the final stages of the reaction, it is not different from your usual pathway. So by using a catalyst, yeah, that's where your points about delta G does not change. Equilibrium constant also does not change. Arrhenius factor also does.
What is that? Sorry, what is that red arrow?
This one?
Yeah.
You tell me, what is this?
Delta H.
Yeah. So with or without, delta H remains the same. Delta S also remains the same, essentially. So that's why your delta G also is the same.
Miss, when we were doing threshold energy as well, now also, what does it mean when we say intermediate has energy? Means what? Like what does it mean?
You understood the concept of like reactants and products having like a specific value of energy, right? Their potential energy
Yeah,
there in their,
yeah, that I got.
right?
Yeah.
So same thing for the intermediate.
म्हणजे intermediate का potential.
Yeah.
Okay. So, like to facilitate the forward reaction, the intermediate needs to have a certain amount of potential energy, and that energy we say threshold, right?
Phrasing is different. To facilitate a reaction, the intermediate
Hmm.
needs to be formed and it happens to
Hmm.
have an energy associated with it because intermediate is also like a particular formation of atoms and molecules. And
Yeah.
for the reaction to happen, it needs to reach the
Hmm.
intermediate. Matlab, it needs to gain that much amount of energy so that the intermediate can be formed.
So that is activation energy, no? To reach that.
Yeah. So then we'll talk about characteristics of a catalyst. So one is characteristic. You only require a small amount of catalyst because every time for every set of reactant molecules, and then you're getting the catalyst particles back. So the same catalyst can be used again for a different set of reactant molecules. So because you're reusing, recycling within it, you only require a small amount of catalyst. Like um you don't have to look for stoichiometric ratios with respect to the reactants or products when it comes to the catalyst.
What is that T? Catalyst?
Yeah. I wanted to use C, and then I realized no, CD are already products. That's why I switched to P. Um, so it does not change the delta G of the reaction. So Gibbs free energy is the same. So अगर exothermic है तो it is exothermic. Endothermic है तो endothermic ही होगा. It also does not like shift the equilibrium this way that way because catalyst ka role is simply to become this intermediate. So even when the reverse reaction is happening, same effect will be there. C plus D are capable of forming this intermediate to give back A and B. So yeah, like it just makes the reactions faster. It does not change any other thing with respect to the equilibrium or the energy changes. Only makes the reactions faster. It's not change anything else. So a significance of the fact that it does not change delta G is that if you have any non-spontaneous reaction, catalyst is not capable of making it spontaneous. So it can't make an impossible reaction possible.
But non-spontaneous reactions are possible. No? Wait, they're not possible.
They are not spontaneous. Yeah, you need to, like, if it is naturally non-spontaneous, you can't make it spontaneous.
Out non-spontaneous as in you'll have to provide energy for it to happen, right?
No, like when delta
Whereas
T is positive, the reaction is not
hmm.
feasible at all. Like not spontaneous.
So it'll like won't happen only वैसा अच्छा.
Yeah. So you can change the temperature and everything. We're just saying catalyst will not help in that regard.
So, but like you can make a non-spontaneous reaction spontaneous by changing conditions, right?
Yeah, by changing conditions, yes. Catalyst is not one of those conditions.
Yeah, okay.
Another thing, because it's forming its own intermediate and everything, is also the fact that catalyst is extremely specific. So if you take the same reactants but use a different uh, catalyst, you will get a different product, because the intermediate formed is associated with the catalyst, right? So agar different intermediate form hua to different may rearrange into completely different product.
But the catalyst does not take part in the reaction at all. So how will it change the product?
Okay, phrasing again. Does not take part in the reaction matlab overall net it is getting regenerated, but it is taking part in the reaction in a way that it's forming this alternate intermediate, and it
Hmm.
is the intermediate that will decide okay what products are going to be formed. अगर
Right.
intermediate अलग हो गया, so then like
Hmm.
intermediate is basically the reactants only, but in like a specific arrangement of molecule. Like the bonds and all, there are some half bonds formed. There are some about to break. It's like transition state. It's in the middle of this thing, right? So अगर उसका structure different हुआ, तो your end product also will be different, ना?
Ma'am, but suppose we have the normal reaction that A plus B gives C plus D. Then if you put a catalyst, then it gives A plus, then the rate becomes faster. But if you put another catalyst, why would you get a different one? Like it's just normal reaction but with a different catalyst. I didn't understand that.
Because the intermediate that is formed is different, इसलिए.
But for a particular reaction, only one, like, it's reaction specific, right? For a
Yeah.
particular set of reactants, only few, maybe only one a catalyst can work. That is why for every,
It is reaction specific. Yes, only some of
yeah.
this will work. Reaction involves not just the reactant, but also what products they're being formed, right? So from A plus B, if you want C plus D, you use a catalyst P. But if you want Y plus Z, maybe use a different catalyst. I think like in the body only there may be some reactions that happen this way. Like if you give it, if there's like one hormone or like a neurotransmitter involved, you end up with a different effect. And but if you have like a different neurotransmitter or a different thing involved, um, then you might end up feeling different effects of it, right? If I remember,
Isn't that what happens in phenylketonuria? Arya.
I don't remember.
which one?
Okay.
Yeah.
Phenylketonuria. It's like a disorder.
Oh,
Mendelian.
okay.
Where did you read? Where did we read that? Like, different um, reactants form. Oh yeah. Ketone. Yeah. Ketone bodies one. Yeah.
Okay. And that's it. That's what we've checked: the effect of catalyst, effect of temperature. That's it for this chapter, guys. Overshot it by a little bit. Okay, we'll start electrochemistry for this. Smara, you didn't have electrochemistry abhi for this exam, right? Uh, how much of it do
No,
you remember though?
some parts like the E naught cell wala calculations. ma'am had.
So if we like basically refresh the formula, if we revise it, we'll be able to catch up with it.
Mostly, actually, again, as I've said, we have two different teachers taking up like the